Hi guys, I've been wanting to do a deep dive into dental health for some time now, but my life has been in a bit of a transition for the better part of the year, so I didn't have the opportunity or the bandwidth to sit down and record a video for you until now. Today's topic is a very personal one to me, which means that I've been quite invested in getting to the bottom of the matter. If you follow me on social media, then you might know that a few years ago, I did a webinar about why people develop tooth problems on the raw Fruitarian detox. And while much of that information still stands, I have done a lot more research since then, including spending $1,500 on a holistic dentist who did a number of tests to help me figure out what specifically could be causing my tooth issues. And just to be clear, this did not involve any work on my teeth. No fillings or restoration. All that money was spent exclusively on a fishing expedition. I got a CAT scan, x-rays, and various saliva tests. I also had the opportunity to interview the dentist, so the money was worth it, if only to find out that even holistic dentists have no clue about the true root causes of tooth decay, which is scary because the best current treatments are based on a model that isn't even accurate. But before we sink our teeth into this juicy discussion, I want to remind you to subscribe, like, and follow if you find the information I share on this channel interesting or useful. Doing so will signal to the YouTube algorithm to push the video forward so that more people who could benefit from this information can find it. Most of the information about teeth that's currently floating around the detox stratosphere doesn't quite cut the mustard because it doesn't offer long-term solutions, which is why many people continue to struggle with enamel loss as well as the overall healing on the raw fruitarian diet. I have a number of clients who deal with this problem, not to mention the people who keep contacting me on social media about teeth. So I know that this is a serious and persistent issue that hasn't been quite resolved. The advice you get from various sources is vague, generic, and most definitely incomplete. Even the protocols that I myself have previously outlined alleviate and manage symptoms only as long as you're applying them. But the goal is to find a permanent solution that will not only stop the decay dead in its tracks, but reverse it. Because if you have to be an ever-vigilant slave to time-consuming rituals and procedures just to keep the teeth in your mouth, then you haven't really solved anything. You're simply continuing to swim against the current, and it's exhausting. Trust me, I know. The reason there seems to be a lack of solid information is twofold. Number one is the way that the medical establishment operates, which is that once a consensus has been reached regarding a specific issue by the majority, that consensus is upheld regardless of any new or more accurate information that may be uncovered. Due to the rigidity of the AMA, which as many of you know is very resistant to change, such consensus oftentimes turns dogmatic and becomes very difficult to overturn. I touched upon this concept when I discussed lymph filtration by the kidneys in the webinar I did on urine therapy. Even though it has been now proven by the mainstream medical research that our kidneys do in fact filter lymph, if you ask any doctor or open an A&P textbook, you will find nothing to confirm this. The information is there, documented and available to those who have the tenacity to look for it. But even if you do find it, good luck bringing it to your doctor in the hopes of getting a more effective treatment. Similarly, the information I'm going to share with you today isn't new in the sense that the origins of the theory go back to the 1930s. Followed by 25 years of extensive and very thorough research and studies that were done starting in the late 50s. And yet these groundbreaking findings aren't being taught in dental schools. And even my super duper fancy and expensive biological dentist has never heard of them. The second issue stems from the first one, which is that if you want the truth, you can only rely on yourself to get it. The problem is that most people aren't willing to invest serious time and effort, let alone money, on research, either because they truly can't afford it or because they childishly believe that information should be free and expect someone to serve it to them on a silver platter. But in reality, studies require a lot of funding to pay the researchers' salaries, as well as to finance the costs of biological specimens and the lab equipment over a significant period of time. These studies run between $1.4 and $6 million per year, so I'm not sure why people expect the fruits of such investment and labor to be given away for free. I mean, that's just common sense. But getting your hands on the research is just the beginning, because you still have to parse through the dense scientific data, which doesn't exactly read like a beach novel, and then you have to decipher those findings in the context of what you already know. Obviously, we don't do this work just for the sake of an exercise. We study the data and connect the dots to come up with applicable solutions to fix specific problems. And that's why we first devise experimental protocols, which we then put to the test in order to verify their efficacy before we can start recommending them to clients. So the never-ending search for truth is energy, cost, and labor-intensive. Luckily, I happen to enjoy the process of solving the good puzzle. Now, bringing you this information today doesn't mean that what I had previously shared on the subject of teeth is not valid, but it only painted a partial picture. And having spent a lot of time and effort on research, as well as money, I finally have the keys to the kingdom. And I will synthesize and share some of this information so that you can gain a better understanding about your oral health. Sharing this knowledge for free in the public forum is my way of giving back and being of service. And sharing it in this video format is the most efficient way to reach and benefit the greatest number of people. I want to reiterate that I do not give health advice through email or social media, so if you have specific questions that you would like me to address, please book a consultation. And now, without further ado, let's bite into the subject of dental health. I'm going to address a number of different aspects today. One is how our teeth work and the processes that affect their structure and health. 2, why some people experience dental problems when they switch to the raw fruitarian diet. 3, the systemic nature of tooth decay. 4, how the condition of our teeth impacts our ability to detox and heal. And 5, what are the best or least harmful restorative dental treatments and procedures. It's a lot to take on when it comes to this complex and multi-layered subject, so I hope that I can do a good enough job explaining it. The first thing to know is that in spite of appearing as tiny, inert, rock-like formations in our mouths, our teeth are living, breathing tissues. They take in nutrients, excrete waste, and their cells die and regenerate in the same way as the cells that make up our heart, liver, or spleen. But for some reason, we treat teeth differently than we do the pancreas or the intestines, even within the natural health space. As I already said, tooth health is an issue that's very personal to me, and I have been on a quest to find answers. What always stumped me was why some people who go full frugivore don't experience any problems with their teeth in spite of never implementing any special dental care regimens. Whereas I can oil pull multiple times per day, apply protective essential oil serum to my teeth, drink my juices strictly through a straw, rinse with baking soda, take sea moss and parathyroid glandulars with vitamin K, but as soon as I put lemon on my salad, my teeth get extremely sensitive and start melting right out of my mouth. I'll never forget the first time I had experienced such accelerated enamel loss. It started on day 5 of my first watermelon juice feast, and it's been downhill ever since. Of course, now that I have learned the information I'm going to share with you, I have gotten a lot more control over my dental health. And I am in the process of healing, because as you know, healing is a process. It's not magic, especially when we're talking about systemic issues. And the word systemic is key here. This discussion calls for a little historical context. It's interesting that on one side of the medical science, Pasteur was hailed a hero in immunology for his incorrect germ theory, upon which much of modern medicine operates. That's your antibiotics, vaccines, and so on. Similarly, the field of dentistry is based on the Miller's acidogenic theory, which postulates that demineralization of tooth enamel is caused by the acids that are formed as a result of bacterial proliferation in the dental plaque. So essentially, both theories blame bugs. Yet despite being outdated and proven wrong, they continue to inform the medical treatments that are currently being used in medicine, even though they have actually been shown to be harmful to patients. Through the 1930s, there were 2 tracks of investigations in dentistry. The dominant track favored the acidogenic theory, and the less popular track examined the possible role of systemic factors. In fact, it was 1929 when CFA Bodecker had first observed the controlled flow of a fluid substance from the pulp of the tooth to the outside through the microscopically porous structures of dentin and enamel, leading him to propose a new theory of the cause of dental caries. Unfortunately, it didn't garner much support, and in 1940s, at the International Association of Dental Research Symposium, a vote was held, and Miller's acidogenic theory won, establishing it as the standard operational framework by the industry majority. This vote effectively cemented Miller's acidogenic hypothesis as the foundation of modern dentistry. The investigators in the less popular camp, who theorized about the existence of a dentinal fluid transport system that begins at the level of the odontoblasts and extends extends through the dentin were completely disregarded. Thankfully, that did not stop some of the dissenters from continuing to investigate this angle because it paid off big time. One of them, a dentist named Ralph Steinman, recruited an endocrinologist, John Lenora, and together they proved interactivity between the oral cavity and the metabolism of the body. Their findings on the hormone axis-mediated dental karyostasis were published after 25 years of thorough research. When I went to my holistic dentist, where I was tested for all kinds of things, my saliva test showed that it was acidic. Of course, the dentist said, well, there you go, mystery solved. However, what Steinman and Lenora found is that there is no correlation between the amount of acid produced and the incidence of cavities. That is not to say that acid doesn't demineralize teeth, because it does. But what these doctors found is that tooth decay results from the disruption of normal tooth metabolism instead of the exocrine factors like acid and bacteria, because our teeth have a built-in internal mechanism specifically designed to safeguard our teeth from destruction by acids and pathogenic microorganisms. And this mechanism consists of lymph-like clear dentinal fluid that cleans our teeth from inside out and seals the outer tooth surface by forming a protective barrier against acids and bacteria. So if you're losing enamel due to acidic saliva or ammonia that are being regurgitated from the gut, or if your teeth are decaying from consuming acidic fruits, or any fruits for that matter, then what you have is a systemic problem. And the key to this issue lies in your endocrine system. You can run interference trying to ameliorate and minimize the external factors by oil pulling or increasing minerals, but this will not help until you fix the underlying mechanism that regulates the internal dental processes. That's why we see such a range of variations in terms of how different people are impacted by the fruitarian diet, where some can drink straight lemon juice and keep strong, healthy teeth without an ounce of sensitivity or irritation, while others can take all kinds of precautions and still continue to see their teeth deteriorate. The first thing I'd like to convey is that teeth are not as solid as they appear. They're made up of a series of dentin tubules and parallel enamel rods. Dr. Steinman proved that systemic substances move from within the body through the pulp chamber via the interstitial fluid into the dentin tubules, as well as through the enamel and into the mouth. In other words, internal systemic bodily fluids find their way into our teeth and mouth from inside out. This was confirmed by injecting radioactive contrast dye into the stomachs of rats. It was found that the dye injected into the rat's stomach made its way into the dentin tubules within 6 minutes and into the enamel within an hour. This means that the condition and the contents of the gut have a direct impact on the state of our teeth. The dye was transported into the teeth by what the researchers termed as dentinal fluid. In their work, Steinman and Lenora refer to it as lymph-like fluid, stopping short of calling it lymph, mainly because it was found to flow bidirectionally, whereas lymph is thought to only move in one direction. However, in the 2017 study that I mentioned earlier, which dealt with the lymph filtration through the kidneys, it was found that in the kidneys, lymph does in fact flow in both directions, and I think that there will be more areas found in the body where this occurs, thus overturning the outdated notion that lymph can only move in one direction. Given that the dentinal fluid experiments ended in 1980s when the funding dried up, I understand the researchers' reticence to define dentinal fluid as lymph, because at the time, the accepted position within the medical establishment was that lymph can only move unidirectionally. So that's just a small side note on the nature of the dentinal fluid, which may very well just be good old lymph. Having observed the contrast dye injected into the rat's stomach travel into their teeth, Steinman believed that this dentinal fluid action was a self-cleansing mechanism where a constant flushing of the inner tooth structure by the dentinal fluid prevents the movement of bacteria into the tooth and prevents the destructive effects of acids formed by foods. At the same time, essential nutrients are brought by this dentinal fluid into the dentin tubules in order to provide a life-supporting environment for dentin, which in of itself is devoid of any blood supply or nerve innervations. So the dentinal fluid serves as the interface between the pulp, which has the blood and the nerve supply, and the dentin, which has none of those. Yet dentin is where the tooth stem cells are formed, which are later utilized for the remineralization of the enamel. Let's look at the structure of the tooth using this diagram so that you can visualize what I'm talking about. As you can see, underneath the enamel you have dentin, which is composed of tiny tubules called the canaliculi. They radiate from the interface between the dentin and the pulp. The odontoblasts are responsible for the secretion of dentin matrix and maintaining its vitality. Since dentin is a living tissue, it requires blood supply. But as you can see from this picture, blood supply terminates in the pulp chamber. So how do nutrients get into the dentin? Well, the odontoblasts is where we find the dentinal fluid, whose job is to transport nutrients derived from the blood into dentin, as well as to cleanse and protect it. When Steinman first recognized the significance of dentinal fluid transport, he didn't know its regulatory mechanism, though he suspected the dental processes were impacted through the involvement of systemic mechanisms, which is why he teamed up with John Lenora, who was an endocrinologist. In this collaboration, Steinman was in charge of the dental aspect of the study, like sectioning the teeth and measuring dentinal fluid transport, while Lenora was responsible for identifying the hormonal mechanisms in charge of stimulating dentinal fluid flow, as well as isolating the specific hormones involved. It was through this work that they discovered the hypothalamic parotid gland endocrine axis. The parotid gland, which you can see here, is a major salivary gland, and we have one on each side of the face located in front of both ears. The parotids are the largest of the salivary glands. Each parotid is wrapped around the mandibular ramus and secretes saliva through the parotid duct into the mouth to facilitate mastication and swallowing and to begin the digestion of starches. While the parotids are responsible for only 20% of the total saliva secretions, they play an extremely important role as a part of the endocrine system. In fact, all of the salivary glands are now recognized as endocrine glands. Major problems occur when endocrine function, poor diet, or stress negatively affect the hypothalamus, which regulates dentinal tubular flow via the parotid glands. How this works is that the hypothalamus tells our parotid glands to secrete the parotid hormone, which then stimulates and regulates the flow of the dentinal fluid inside the teeth, as you can see depicted here. The parotid hormone appears to alter the permeability of the odontoblast membranes, which enables the movement of nutrient-containing fluid into the odontoblasts. It's important to note that the parotid hormone has no known digestive function. Its only known role is to stimulate the movement of fluid from the general circulation into the dentinal tubules of teeth. Circulatory problems associated with poor health or aging affect this dentin tubular flow, leading to flow reversal and stagnation. Our odontoblasts, which are right outside the dentin tubules, contain cytoplasmic myofibrils that enable them to function as the pumps for the dentinal fluid. A myofibril is a basic rod-like organelle of a muscle cell. When lots of these cells come together, they compose muscle fibers. So the odontoblasts in our teeth contain tiny versions of these starter muscle fibers that expand and contract similarly to our biceps. And that's how they pump dentinal fluid into the dentin. Steinman demonstrated that odontoblasts were hormonally and biochemically linked to the metabolism of the body, as well as to the health and function of the teeth. If odontoblasts cease to pump fluid, capillary action sucks bacteria and other toxic and corrosive materials from the mouth or the surrounding periodontium into the tooth. This leads to microbial contamination of the interior structures of the tooth, causing biofilm to form within the dentin tubules. Physiologically, dentinal fluid flows in a centrifugal motion, meaning from the center outward. It penetrates the enamel and coalesces on the surface of the tooth, forming a fluid layer. If there are cracks in the enamel, the flow of the dentinal fluid is increased, causing more of it to be pushed through the enamel and accumulate on the surface. You see, the hydrostatic pressure inside of the tooth is greater than the external oral pressure, which is how acids and harmful bacteria are kept from being able to enter the tooth, thus preserving its structural integrity. When this dentinal fluid transport is altered, we experience enamel erosion and tooth decay. Steinman produced many slides demonstrating this flow going in both the centrifugal and centripetal directions. This is important because the latter causes the tooth to pull all kinds of destructive, noxious debris from the oral cavity into the teeth like a vacuum. This means that under certain conditions, the internal centrifugal pressure can flip, causing a reversal of the normally outward bound dentinal fluid to switch to an inwardly focused direction, where it begins to actively pull things from the mouth into the teeth. Since the tooth is not an isolated structure but an open system, it's not possible to maintain a sterile environment within it for any length of time. So the job of the dentinal fluid is to constantly cleanse our teeth from inside out like an internal toothbrush. However, when we have a problem with our hypothalamus or the parotid glands, or both, this mechanism does not function correctly. One major factor that was found to affect the activity of the dentinal fluid was the diet. It's important to note that the nerve endings in the tongue and the mucosa of the mouth can distinguish between nutritive and non-nutritive substances. An avocado, for example, is nutritive, but ice chips are not. Now, the receptors in our mouth can tell which is which. When a nutritive substance is detected, the mouth receptors send the signal to the hypothalamus, which then directs the parotid gland to secrete the parotid hormone. And it's the parotid hormone that stimulates and directs the flow of the dentinal fluid. What was interesting is that when non-karyogenic diet was fed, dentinal fluid moved from the pulp-dentin interface into the dentin-enamel interface within 30 to 45 minutes. However, when karyogenic diet was consumed, which in this case is high sucrose diet, the fluid reached the pulp but did not penetrate beyond the odontoblast layer, leaving the dentin and the enamel unprotected. Complex sugars especially inhibit the flow of the dentinal fluid because this type of diet suppresses the parotid hormone secretion, which is why you can see the breakdown of tooth enamel in those who drink soda and eat a lot of sugar, grains, and starches. Sucrose was found to be especially destructive. So let's talk about the elephant in the room and the reason we're here today, which is the impact of the fruitarian diet on tooth decay. Now, it's been drilled into us by Dr. Morse that fruits only contain simple sugars like fructose and glucose. But surprise, surprise, sucrose is found in many fruits and vegetables. In fact, some fruits contain mostly sucrose, while other high-sugar fruits contain no sucrose at all. Those that have the highest sucrose content are mangoes, peaches, dates, as well as all the other dried fruits, followed by mandarins, clementines, tangerines, pineapple, apricots, bananas, nectarines, pink grapefruit, cantaloupe, and navel oranges. Notice that many of these are acidic fruits, like the citruses and the pineapple. It turns out that this whole time we've been worrying about the wrong thing. We were avoiding acid fruits out of fear that their acids would degrade our teeth, when the real villain is sucrose. When it comes to vegetables, peas, carrots, sweet potatoes, beets, and corn are loaded with it. I was also surprised to find out that many nuts made the list as containing notable levels of sucrose. On the low end of the sucrose spectrum, we have berries, cherries, avocado, cucumbers, lemons, and even grapes. So if you have underlying issues affecting your hypothalamus parotid axis, it does make a difference which fruits you choose to detox with. In fact, you may want to start your healing journey with non-sweet fruits and vegetables while you're getting your endocrine parotid axis back in shape in order to prevent possible tooth deterioration. Fruit-induced tooth decay can also happen as a result of poor digestion that leads to fermentation. It was observed that the sugar-rich diets cause an increase in caries when fermentation of carbohydrates occurs. Fermentable carbohydrates are found in fruits, grains, potatoes, and dairy, which explains why consuming dairy for calcium has been proven to be a big fail, study after study. Now, there's more than one reason as to why even simple sugar metabolism could be impaired. Adrenals, for example, play an important role in sugar metabolism, and a vast majority of people who embark on the detox journey have serious adrenal problems, often causing insulin resistance. Problem is that most people aren't aware that they're insulin resistant. Most type 2 diabetics have been insulin resistant for decades before finally getting diagnosed. For example, if you have dark circles under your eyes or skin tags, you are insulin resistant. Other signs of insulin resistance are not feeling satiated after eating and frequent sugar cravings, especially after a meal. Also, swollen ankles. Insulin tells the kidneys to hang on to sodium and water. Therefore, those with insulin resistance will look more puffy and can experience fluid retention anywhere in the body. Acne, large pores, swaths of dark discoloration on the neck, thighs, abdomen, abdomen and under the breasts, as well as hair loss in women, are some additional signs. Insulin resistance was shown to play a role not only in tooth decay, but was specifically implicated in gum inflammation. Additionally, chronically high blood sugar makes the blood acidic, resulting in the loss of minerals. This is a consequence of the calcium buffering mechanism, where minerals are pulled from our bones and teeth, causing the body to demineralize. This increases serum calcium, which in layman's terms means high levels of calcium in the blood. So if you start eating a ton of sugar-rich fruits while being insulin resistant, don't be surprised if you start losing your teeth. Other contributing causes of impaired sugar metabolism could be attributed to insufficient HCl production, combined with poor pancreatic function and liver gallbladder problems. Another factor would be improper food combinations or eating fruits that are overly ripe and are already fermenting. Tooth decay was also exacerbated by the early loss of magnesium, copper, iron, and manganese, all of which are active in cellular oxidation and are necessary for the metabolism of the odontoblasts. Steinman showed that adding copper, iron, and manganese to cariogenic diet effectively halted the decay rate. I want to elaborate on the mechanism of how the high sucrose diet leads to tooth decay. It's been established that an increase in the rate of the dentinal fluid transport results in a significant reduction of dental caries. On the other hand, a high sucrose diet was found to affect the rate of the dentinal fluid transport by decreasing it in half. An excess of sugar does not only block the centrifugal flow of the dentinal fluid, but it also causes it to reverse direction and draw inward, encouraging rampant caries. Furthermore, a high sugar diet was shown to reduce odontoblast function. This is important because odontoblasts regulate the secretion of fibrillar protein matrix of the predentin and the subsequent initiation of mineralization. In other words, odontoblasts play a role in enamel building, and sucrose alters this process. But here's the kicker. When rats with removed parotid glands were fed non-cariogenic, sugar-free diet, their ability to build enamel was impaired on par with the rats fed a high sugar diet, though to a lesser degree. This led the researchers to conclude that the sucrose effect on dentinogenesis is not sugar-specific, but is rather parotid gland dependent. This is important because while sugar is definitely a factor in tooth decay, it's not actually the main culprit. The problem with the sugar is that it suppresses and alters the function of the parotid glands. In fact, it was found that a high sucrose diet caused the parotids to significantly atrophy. From an endocrine perspective, the parotids have more than one function. They're involved in the regulation of the dentinal fluid transport, and they're also involved in dentinogenesis. So if your parotids don't work, not only will you lose enamel, but you will also be unable to replace it. When a sugary diet was combined with the absence of the parotids, the inability to rebuild enamel was greatly exacerbated. To ensure that this particular role could only be attributed to the parotid glands, similar experiments were carried out by removing the submandibular sublingual gland complex, which had no effect on either the dentinal fluid transport nor the dentinogenesis. Another important thing that has to be addressed here is the impact of the texture or the consistency of the food on tooth health. And those of you who love juice feasting are not going to like this. You see, the very act of chewing activates parotid salivation and therefore the secretion of the parotid hormone, which is needed to stimulate dentinal fluid flow. The doctors who did these incredibly important studies experimented with different forms of chow and pigs. Feeding pelleted, solid food triggered an acute release of the parotid hormone, whereas feeding the same exact food that was ground up into fine powder triggered a very weak response, which was on par with the response observed on the cariogenic high sucrose diet. It was further found that a liquid diet significantly decreases salivary flow and protein content, resulting in seriously reduced parotid hormone levels. So the act of chewing is extremely important for maintaining tooth health and vitality because it stimulates a stronger digestive response, which in turn leads to an increased flow of dentinal fluid. So the effect of the dentinal fluid action is twofold. One is to initiate the cleansing process so that whatever we're eating doesn't damage our teeth. And two is to utilize the nutrition from the food by bringing it into the dentin. Knowing this, it now makes perfect sense as to why my initial tooth deterioration got triggered by my very first juice feast. That being said, I believe that this effect will be more adversely pronounced in the individuals who already have an underlying impairment of the hypothalamus hypothalamus parotid axis. Therefore, some people will experience greater tooth degeneration when juicing than others. Additionally, sugary fruit juices will have a greater negative impact on teeth than green juices due to their sugar content. This means that while juice feasting can be great for detox, it may not be the best option for everyone. Nevertheless, there are ways to mitigate the suppressive effects of juicing on the parotid hormone production with specific supplements, which means that you could still go on an extended juice feast by utilizing certain nutraceuticals and adjusting some routines. One important mitigating compound found to inhibit the cariogenic effects of sugar on the hypothalamus and the parotid hormone is an enzyme called carbamoyl phosphate. It stimulates the hypothalamus parotid axis, thus increasing the rate of dentinal fluid transport into the dentin, making it necessary for the mechanism of the dentinal fluid transport to work correctly and at full capacity. Carbamoyl phosphate was also found to significantly inhibit the downregulation of dentinogenesis. In other words, it helped the body generate new enamel to replace what was lost due to the deleterious effects of the high sucrose diet on the odontoblasts, dentinal fluid transport, and the parotid glands. Incidentally, high sugar diets cause the systemic depletion of carbamoyl phosphate, which is normally synthesized from the amino acid called glutamine. Now, if you cannot digest proteins due to inadequate HCl production, then you are going to be deficient in amino acids and may lack the raw materials needed to make carbamoyl phosphate. But aside from tooth decay, carbamoyl phosphate deficiency can also result in toxic levels of ammonia in the body because this compound is involved with the detox of ammonia. I'm sure everyone knows that despite being super alkaline, ammonia is extremely corrosive and has been implicated in demineralization of teeth. Now, the ammonia aspect was an important piece of the puzzle for me because I have a genetic mutation of the transsulfation pathway that does not allow me to properly break down sulfur-based amino acids like taurine, cysteine, glycine, and methionine, as well as all the other methyl groups. This results in excessive ammonia and sulfates accumulating in the body, which are difficult to eliminate. But it's not just about the presence of those amino acids in certain foods, it's also about their quantity and the rate of distribution. You see, different amino acids compete for transport with each other and in that sense could be considered to be antagonistic to one another. So if a plant has a greater proportion of the amino acids that compete with the ones that cause me trouble, then I can eat those plants without suffering significant repercussions. That's why, for example, I can eat broccoli and cauliflower, but not cabbage, kale, or spinach. So when my saliva tested high for ammonia, I wasn't all that surprised. However, there's more than one variety of these mutations that have to do with the detoxification of ammonia and carbamoyl phosphate. The one I have is called the CBS mutation of the transsulfation pathway, but there is another mutation known as the CPS mutation, which specifically relates to the carbamoyl phosphate synthetase deficiency. People with this particular mutation simply cannot make it. And if you lack this enzyme, your ammonia detox will be greatly impaired. Steinman and Lenora showed that supplementing with carbamoyl phosphate stopped and reversed cavities, even with a high sugar diet. So this confirms that there is a definite link between karyostasis and ammonia toxicity. Unfortunately, you cannot buy this compound on the market if you wanted to take it as a supplement. For one, it's insanely expensive and can only be acquired by accredited labs because it's used to make pharmaceutical drugs that treat carbamoyl phosphate synthetase deficiency. And of course, Big Pharma doesn't want you to be able to purchase something over the counter that they're making lots of money from. Now, what you could do, however, is increase its natural production by consuming glutamine-rich foods, unless, of course, you have the CPS mutation, in which case it's not going to help you much. Now, in order to be able to synthesize carbamoyl phosphate, you must ensure that you're making enough hydrochloric acid so that you can actually get glutamine out of your food. The breakdown of proteins into amino acids happens in the stomach. So a problem at this stage of digestion is going to make the proteins you're consuming absolutely useless. Incidentally, low stomach acid causes gut rot and fermentation, creating two additional problems. One is the acidity that's going to damage your enamel, and two is the proliferation of the ammonia-producing microbiota. For example, H. pylori produces ammonia, which goes directly into your teeth via the dentinal fluid. Furthermore, having a compromised microbiome will also impair dentinogenesis, meaning tooth rebuilding, because you need specific bacterial strains to be able to build bone and enamel, like L. rhamnosus and L. reuteri. So problems with digestion are going to impact your teeth in a number of ways. from your inability to break down minerals needed for enamel rebuilding, to proliferation of the ammonia-producing pathogens, to the inability to digest protein, resulting in carbamoyl phosphate deficiency, which in turn impairs your ability to get rid of the excess ammonia. So let's recapitulate the important factors that are involved in tooth health or deterioration. First and foremost is the endocrine system, and specifically the hypothalamus. We now know that poor hypothalamic function will affect the production of the parotid hormone, which is vital for the dentinal fluid transport. This hypothalamus parotid gland endocrine axis is involved with generating dentinal fluid pressure out from the pulp through the natural channels and pores of the tooth structure, thus influencing its external resistance or susceptibility to decay. The protective dentinal fluid carries with it immune resistance capability and buffering capacity, as well as nutritive elements necessary to support the hard structures of the outer tooth. So if we were to chart the course of tooth decay, it would start with the altered function of the hypothalamus and or the parotid glands, followed by the reversal of the dentinal fluid flow from centrifugal to centripetal. The reversal of dentinal fluid flow causes inflammation in the pulp chamber adjacent to the dentin, leading to its breakdown. From there, the disease spreads to the enamel before the actual appearance of the cavity. This means that a cavity actually starts inside of the tooth at the pulp and dental levels, and then works its way outward till it reaches the enamel, which is the complete opposite of what the Dental Association tells us. What a dentist would tell you is that the damage starts at the surface enamel level and then expands inward by eating into deeper layers of the tooth. Unfortunately, there are no tests to determine whether or not you have a hypothalamus problem, but if you know iridology, then it's quite easy to see. A good indicator that your hypothalamus isn't working properly is poor temperature regulation, whether you tend to run too cold or too hot. Appetite disturbances are another big sign, be it the absence of appetite or always feeling ravenous. Additionally, if you have low thyroid function with low free T3, low free T4, and also low TSH, it indicates that there is miscommunication between the hypothalamic pituitary thyroid axis, and that is a definite sign of hypothalamic dysfunction. It's also important to remember that the hypothalamus is in charge of the pituitary, which regulates all the other endocrine glands, and more specifically the parathyroid and the thyroid. Both of these produce hormones necessary for calcium utilization, parathormone and calcitonin respectively. So impaired hypothalamus will cause additional problems downstream, undermining our ability to rebuild teeth. The pituitary is also in charge of the adrenals, which are instrumental in proper sugar metabolism. In the past, I spoke about how heavy metals affect enamel loss. And while heavy metals do become embedded into the bone and tooth structure, the main mechanism of heavy metals' destructive effect on teeth is via the hypothalamus, because heavy metals love to settle in the brain and have a special affinity for the hypothalamus and the pituitary. However, heavy metals are also known to affect the salivary glands, including the parotid. When we detox, we release the metals from our tissues and glands into the interstitial fluid so that they can be eliminated. This often results in the symptoms of acute poisoning, acidifying the body so we feel as if we had just been exposed to the toxic metals all over again, causing toxicity and inflammation. And remember, what's happening in the systemic fluids has a direct effect on the dentinal fluid content and transport. Therefore, detox does indeed alter the functioning of the dentinal fluid. Problems with the liver and gallbladder also suppress the HPA axis. You see, poor gallbladder function causes bile to accumulate and stagnate in the liver, along with other toxic substances. Given that the liver is a blood-making organ, toxic bile inevitably contaminates the blood, which then crosses the blood-brain barrier, and that's how it suppresses the HPA axis. Additionally, compromised bile flow also causes the saliva to become acidic, which combined with the impaired parotid hormone production not only robs our teeth of calcium, but also prevents the repair of our enamel as a result of the reversal in the dentinal fluid flow. But the liver is also involved in the metabolism and storage of the fat-soluble vitamins E, D, K, and A, which are essential for tooth growth and rebuilding. When we switch to the raw fruitarian diet, we lose a great deal of body fat, which is a significant storage depot for these nutrients. This means that we may actually need to supplement them. But the catch-22 is that supplementation will only work if the liver is healthy and able to utilize and store these nutrients. Another thing that affects our hypothalamus is fluoride, which is similar to the effect it has on the pineal gland. Additionally, fluoride, which is used widely in conventional dentistry and dental products to strengthen enamel, also gets embedded into the tooth matrix, where calcium, magnesium, and phosphorus should be. While this does make the tooth harder, paradoxically it also makes it more brittle. The problem is that fluoride was never meant to be in our teeth. So when we detox, it gets kicked out, which unavoidably ends up weakening the tooth structure. And fluoride also damages the parotid glands. Stress is another big factor in the hypothalamic function because chronic stress causes the hypothalamus to shrink. Stress also alters cellular permeability, which is vital both for the elimination of toxins and the transfer of nutrients through the cell membrane. Obviously, if we cannot get nutrients into the cell, we cannot maintain the cellular structure, and we certainly cannot repair or rebuild it. This exchange mechanism is controlled by the sodium-potassium pump, which in of itself is dependent on the proper adrenal function, because the adrenal cortex produces aldosterone, the hormone that regulates the sodium-potassium balance. It's been found that undue stress causes the intracellular fluid to become almost indistinguishable from the extracellular fluid, thus adversely affecting cellular metabolism. What does this mean? Most of the potassium is supposed to be inside of the cell, while most of the sodium should be outside. Sodium has 11 electrons and 11 protons, whereas potassium has 19 electrons and 19 protons respectively. This interactivity of sodium against potassium is what maintains the cell membrane potential, which regulates the exchange of ions across the cellular membrane. And what stress does is that it causes the fluid inside of the cell to become basically indistinguishable from the fluid outside of it, causing the loss of the cell membrane potential. It means that the ratio of sodium and potassium inside and outside of the cell become roughly the same. You know what else has the same effect on the cellular permeability as stress and poor adrenal function? Dietary salt. I've been saying this for years and people continue to argue with me that consuming salt is good for them. But these dental studies unequivocally showed that the retention of sodium chloride, which is nothing but good old salt, overloads and impedes the function of the sodium-potassium pump, making it the secondary cause of tooth decay. Because as we already established, disruptions in systemic metabolic processes impair the hypothalamus-parotid axis. Let me say it again. Electrolyte imbalance is one of the systemic factors that affects caries susceptibility under stress conditions. Additionally, stress affects the mitochondria by causing them to dump their DNA into the blood, which initiates a cytokine storm, also known as acute inflammatory reaction. This has been directly linked to enamel loss because our mitochondria produce ATP, also known as adenosine triphosphate, and ATP has been found to protect tooth enamel from deterioration. So aside from the hypothalamus, adrenals are another piece of the endocrine puzzle because they regulate our stress response, the sodium-potassium pump, and the sugar metabolism, all of which indirectly affect the condition of our teeth. Next on the list is the state of the parotid glands. We have two of them. Each gland may function at a different capacity, causing us to have more tooth-related issues on one side of the jaw. For example, my left side is much weaker than the right. Now, aside from regulating dentinal fluid flow, the parotid glands are also involved in dentinogenesis, meaning the restoration of tooth enamel. The next big thing to pay attention to is the state of your digestion, because without adequate stomach acid, you cannot break down macronutrients like minerals and proteins that are necessary for enamel building. Furthermore, poor digestion leads to acidity, both due to fermentation and due to the lack of bile, which is needed to alkalize chyme. But aside from acid reflux, you could also have bile reflux, which will also damage your teeth just like GERD does. Fermentation that results from impaired digestion causes dysbiosis, leading to the overgrowth of ammonia-producing microorganisms. And ammonia, despite its high pH, will melt your teeth. Now, outside of dysbiosis, problems with ammonia toxicity can be caused by certain genetic mutations that prevent it from being efficiently eliminated. This is something you need to get tested for. You can look for a specific mutation, or you can have your holistic dentist test your saliva for elevated ammonia. Though, as I already said, there's more than one cause for ammonia buildup. Certain amino acids can aid in the removal of ammonia either directly or indirectly. So if you are struggling with dental issues, this is where you need to look to ascertain the appropriate corrective measures that have to be taken in order to stop and hopefully reverse tooth decay. I think I'm going to stop here and break this video into two parts, as I've already been talking for far too long about this fairly complex topic. So why don't you take some time to digest this information and be sure to tune in to part 2 in order to learn how the state of our dental health can sabotage our detox and healing.